Okay, the unplugged activity that I chose to look at and play with is called Beat the Clock, and it's about sorting networks. And so it's designed to show students how computers that are networked and working together can process data faster than just a single computer on its own. So this activity is actually designed to be done outside. This diagram is to be drawn with sidewalk chalk, either in your playground or the parking lot, wherever the kids have room to move around. It's raining outside today, so we're adapting and playing this inside. So you can see the numbers at the bottom of the page. Those are the students. They're each going to hold a number, and they're going to be lined up in whatever random order they happen to be in, and the network is going to sort them into chronological order or numerical order. So we're going to follow the rules that the students are going to follow the arrows into a circle. They can't move out of a circle until there is another student in the circle with them. So if 5 is in that circle, they can't move until this other student joins them. Once we have 2 students within a circle, they're going to compare numbers. The smaller number is going to move to the left. The larger number is going to move to the right. So out of this circle, this guy is the larger one. It's going to follow its arrow to the right. The 3, the smaller number, is going to follow the arrow to the left. Okay, so then we have our next 2 students are going to move into the circle. 6 can't go anywhere until the other student joins. So here again we have our smaller number is going to go to the left. So 4 is going to follow the arrow over here to the left. 6 is going to follow its arrow over here to the right. And then we would have our last 2 students winding up in the first circle. Again, smaller number goes to the left. Larger number is going to go to the right. Now, this is taking a little bit of time because I am moving all of the students. You have to remember that the students will be out there doing this at the same time. So 3 and 4 will be comparing numbers and moving at the same time. 5 and 1 are comparing and moving at the same time. 6 and 2 are comparing and moving. So it should not take the students too long to get to the other side. So here, if we compare, we have 3 and 4. So 3 is smaller, it's going to go to the left. 4 is larger, is going to move to the right. So then we have 5 and 1. 1 is smaller, so it will go to the left. 5 to the right. And then we have 6 and 2. 6 is larger, it will go to the right. 2 is smaller, so it will go to the left. Okay, so we're going to keep comparing. So here we have students 1 and 3. 1 is smaller, so it's going to go to the left, and notice where it wound up. It wound up in its correct first position up there at the top. 3 was larger, so it'll move to the right. 2 and 4, 2 is smaller, so it's going to go to the left, 4 to the right. 5 and 6, 5 to the left, 6 to the right. Notice it ending up in its natural position where it's supposed to go. If we compare our 2 and 3, 2 is smaller, so it's going to go to the left, again winding up in its proper position. 3 larger to the right. Here we have 4 and 5. 4 is smaller to the left. 5 is larger to the right. And then here we have our 3 and 4. So 3 is smaller to the left. 4 is larger to the right. So again, it doesn't matter what order the students start in, the network will sort it into the correct chronological order. So you can adapt this and change it for older students, make it a little more rigorous by changing up the numbers, throwing in larger numbers for students to compare, maybe choosing numbers that aren't consecutive for students to compare. You can also change the pattern of the network to some other designs. So here are a couple examples from the textbook of a couple of other ways that you could set your network up to have students explore. You can also have them work it in reverse to see where they wind up.